It's short.
Okay, we good? Can you hear me? All right, so good afternoon. I know it's kind of late in the day, but if you want to jump around a little bit, that's fine too, you know. So my name is Billy, and that's Parin. We're from Intuit. We're a platform engineer at the payment. So what we're going to talk to you guys about today is how we kind of revamp our whole deployment system with Kubernetes and the experience and the speed that we learned came from the whole experience. So the agenda first, I want to just kind of go through this is we're going to give you a little background about how DevOps journey. So we moved from data center to EC2 Spinnaker and then with Kubernetes. Then I'm going to give you a detailed comparison between like how the deployment is different between using Spinnaker versus Docker and Kubernetes. And that lead to what our big initiative called Intuit Modern says is how we bring it all together so that our developer really doesn't have to know too much about the detail, but they just get to focus on what they need to do best is coding feature for our customers and deploy anytime they want. And along with that, I'll talk about why we also decided to build a CD continuous deployment tool called Argo CD. And after that, Parin will give you a full demo end-to-end. You can see how everything works together. Sounds good? Before I start, does anyone know about EC2, Spinnaker, that type of couple hands? At least some, because I'm basically making a comparison. Great, okay, good. If not, I'm trying to give you a little bit more detail, but that's not the intent for this talk, so. Now, before that, of course, I'm gonna show you a little bit, talk about our company a bit. We work for Intuit. Just make sure to echo. Our company mission is to powering prosperity around the world. What we mean by that is we want to provide the best financial tool to make your company successful, whether it is accounting, payments, payroll, or tax, right? And of course, our flagship product of TurboTax and QuickBooks, I'm sure some of you have heard of it. We're actually in Silicon Valley, in Mountain View, next to Google. Our company was founded in 1983. We went IPO in 1993, and we have about 9,000 employees in 21 locations globally. We did about $6 billion revenue last year, and we have about 50 million customers worldwide. So just give you some context of company size. Now, for our DevOps journey, I want to just kind of give you start from the beginning where we're at. Given the age of our company, we started from, of course, data center. We have our own data center. And the way we operate before was basically, engineer focusing on development, and we have a dedicated ops team that would do the deployment for us. And we also have a platform infrastructure to maintain our data center infrastructure. The challenge with that is basically, if you think about, let's just say we do a 2-week Scrum. From the time I develop a feature, by the time I need to schedule deployment time, that will take about 3 weeks. We're talking about weeks to get features out. And then when we have to do any changes for the infrastructure, meaning like need to order a new server or network changes, now you're talking about months, right? So that's kind of the motivation for us to move to AWS, right? So when we move to AWS, essentially we kind of make engineer that responsible for both of course, development's still there. Now they get to deploy anytime they want, but they also need to own the infrastructure. It turns out it wasn't quite, from our learning, it's not the perfect, it's not such a great idea at the end, because what we really want is allow engineers focus on what they do best, either Java or Node.js or JavaScript, whatever it is, and deploy anytime they want. But we don't want to burden them with all the AWS, expertise, right? That takes away time for them to focus on what they do best for our customers. So that's why we decided to invest in a new initiative called Modern SaaS so that we can solve for our engineer the right way, basically let them code a feature as much as solve for the customer problem and deploy anytime they want, but then we have some central team to help manage this infrastructure and also give a common way to deploy code. Right? And I just want to give you a kind of what we're trying to accomplish here. So once we moved to AWS, we were able to release our feature under a week. Literally from some coding to actually get it out, we can do it in a week. But of course, we like to get feature out to customers as soon as we can, right? So that's why we decided to looking into leveraging Docker and Kubernetes so that we can actually literally deploy daily. so that we can get feature out to customer as soon as possible. And also the other side benefit to this is think about recovery, right? A lot of time when you have a deployment problem, the first thing we're going to do, rollback, right? So with Spinnaker, because it's still based on EC2 technology, it actually takes about 30 minutes to do a rollback because you actually have to spin up, all your AMI again. But with Kubernetes Docker, because it's only a process now, so literally we can roll back in 3 minutes, right? So that really helps with recovery too. So I want to give you a little detailed comparison. I kind of studied, just gonna stay away from that side, about how it's different. How do we achieve the time saving between using Spinnaker versus moving to Docker and Kubernetes? So if you think about what's a deployment, really it's more than your code, right? You write the code, you create a binary, but then you also need your runtime environment. For example, like if you're running Java, you need your JDK, you might have an APM, like app dynamics to monitor your JVM, et cetera. So those things all have to be installed in your environment. So then here comes the problem, right? So if you need to deploy that every time into your AMI, the left side is more like how you deploy AMI in Spinnaker. In your build time, you need to download all the chef script. That actually, what we learned is actually taking almost extra 10 minutes to your build time because you have to download a lot of extra things and bundle that into your deployment package. And I don't know if you guys know about AMI Bakery. There's a concept called AMI Bakery. Essentially, is you can actually create immutable image with all your dependencies. What it really does is actually spin up an EC2, execute all your chef recipe to do all the installation, and then snapshot it. Guess what? That takes another 10 minutes, right? So literally the whole build process, just that alone will take 20 minutes, right? So moving over to using Docker and Kubernetes, what we learned is really, remember, Docker is just a virtualized file system, right? So everything we needed, literally we can just put into the base image. Every time we build, we just overlay with the app code. So now the build time is the same between the app code, but the rest of the time literally takes about a minute or less. Because all we need to do is just lay the code over and then create a Docker image for deployment and check it in. There's one more subtlety, and it's going to mean something later on in the talk, is when you need to deploy, so that's just your binary, but you also need to have application configuration to change for your environment. For example, your queue environment will be different than your production environment. Your database setting will be different, et cetera. So you need to have application configuration external to your apps. On top of that, you also need to have something to describe your infrastructure. For example, your pre-prod environment might only have 1 instance or 2 instances versus your prod might have 5 to 10, right? So you need some way to describe your infrastructure. Now with Spinnaker basically is a UI tool with a database. So what they do is they keep track of the EC2 size or whatever number of instances in the database. In Kubernetes, the difference is now you actually have true infrastructure as code, right? You describe your environment using YAML. So this is something because we like to embrace GitOps for basic auditability and also control. That's a huge win for us. And I'll show it in a minute. Now, so I mentioned about we invest in this big, this whole big initiative called Intuit Modern SaaS. Essentially, is we tie together, the Kubernetes servers along with all the monitoring. If you look at the middle, it's like app dynamics, Wavefront, Splunk, all those things integrated into basically deployment daemon set in Kubernetes. Along with what's on, if you look at the GitHub, that line right there, these are all the one we use, the technology we use for CICD Pipeline, right? So we have consistent pipeline for every development. It doesn't matter if it's a small job versus a full-blown service. And Parin will also talk about something not quite directly related, but it's how we internally manage all the clusters. Remember, we have many, many clusters within our company. We also have a homegrown tool called IKSM that will help us managing multiple clusters. So of course, for our talk in particular, we're just going to focus on the CI/CD pipeline. That consists of using GitHub, Blueish Jenkins or Jenkins 2.0. Artifactory is a Docker registry, and the continuous deployment called Argo CD, which we open source to the public. And I believe other talk probably mentioned that already. Now, I know the first question some people might ask is, why not just use Spinnaker? Because Spinnaker actually has a cloud driver that works with Kubernetes. So we actually studied the problem a bit, and I'll kind of go through why we decided not to use Spinnakers. Spinnaker, the good thing is it actually have a very good UI for you to monitor your EC2 fleet. So it really built natively, but even though they try not to be, but it's more fitting about monitoring your EC2 and ASG. Storing infrastructure data in database, like I mentioned earlier, is a good and bad thing. It's a separation in the CFN, but also it doesn't allow you to do infrastructure as code. Good thing, support immutable image, right? Cloud-based deployment, you want immutable image. So that allows for easy rollback and easy redeploy to any environment. But on the flip side is, because the UI is built in such a way it's very ASG, easy to centric, it doesn't support native Kubernetes resources, meaning like in Kubernetes, you have something called ingress, servers, deployment, pods. It doesn't represent those concepts well, right? And the point I keep going back and back again and again is about it doesn't embrace infrastructure as code. And with AMI, the bakery process takes about, it's probably not quite an hour, but sometimes it could take up to an hour to complete the bakery process. And every time you deploy, you need to do an EC2 startup, right? That's why the deployment takes about 20 minutes. So, then we also look around and say if there's any any Kubernetes solution out there that we could use for deployment. The first thing we found was called K8s. That helps with generating a YAML for specific environment. Basically, K8s lets you do is you can create a base YAML for your environment, but then you can override different portions of it for different environment. But that's only one piece of the puzzle, right? We like to embrace GitOps for environment changes. So once again, why we like that is because this provides with traceability, and with pull requests, we can have some level of approval process to track changes. With that said, then we need something to actually compare the difference between what is in Kubernetes SCD versus in a deployment repo. So that's why we need another tool to give us visualization of the difference so we know what's in a Git repo, deployment repo is actually in Kubernetes. Hence, that's what we built Argo CD in addition to the command line. We have a UI tool that helps you do rollback, deployment, and synchronization. Now, next, Prometheus is going to actually walk you through Argo CD at a high level and give you a full demo how everything ties together.
Awesome. Thanks, Billy, for stating the problem. We have the solution right in-house, Argo CD. So what this does, it gives like environment-specific YAML overrides because it's all in Git. You can mention for pre-prod environment, you want to run 2 pods. For prod, you want to run 3 pods. You can have YAML-specific overrides based on your environment. So it's pretty cool that way. It has an excellent UI to monitor a fleet of services. In Spinnaker, if you see, it's mostly EC2 instances. But in Argo CD, you can see Kubernetes service. You can see any sidecars that are running inside the pods itself, replica set, deployment, everything. I'll go over the UI and show you more details about it. Argo CD adoption, it's well received in the community, mainly used for CICD and a lot of machine learning data workflows. A lot of companies have started using it as well. We have Adobe, Google, BlackRock, to name a few. So yeah, let me jump into the demo piece of it. So I wanted to start with Spinnaker. So this is one service that I host. I'm an application developer, not an ops guy. So when this came to me, it was like, hey, you have to handle this and make sure everything is fine with the EC2 instances. If there's an issue, you'll have to debug it. So the first problem we saw is every time you check in code into master, it does a CI in a separate place. We use classic Jenkins. It pulls in all the chef scripts. It takes roughly 15 to 17 minutes to create an RPM. It gets uploaded into S3, and then it gets pulled in here. This entire process from check-in into master, and if you want to deploy into production, would take roughly 90 minutes. you see these red boxes where we have like manual gates to make sure it doesn't go ahead of that. One cool thing I really liked about Spinnaker was it gave how many EC2 instances we are running for each environment. It gave a lot of, like, if it's healthy, it shows green. If it's not healthy, it shows red. But you really don't know what's happening inside it. You always had to SSH inside the box, look at the configurations. If there's Nginx, you have to go to nginx.conf to see what actually is in each of those. So that became a little tricky, and you always had to be, like, everyone needed to have access as a developer. So
I just want to add a point here. So basically, if you think about what we deploy here is we're actually running and generating a Spring Boot app inside each EC2 instance. Yep. But when you see a green box, all that means is the EC2 is healthy. We don't know what's the pod and the container's health state for this UI.
Yep. So this is the Argo CD UI. This says that this is my E2E environment. This is the application, and this is the pods. Pods are similar to if you're in the Spinnaker world EC2 instance where the application is actually running. So currently in my E2E service, we are running 2 pods. So if I click on this pod, it actually tells me every single thing in the manifest file. And this is from GitOps. This is from Git. Everything's written in Git. And we have parameter overrides that gets overridden. And if there is an issue and there's not a sync, you will clearly see like something in red over here, and you can easily debug it. So you could see every single configuration. There's like Splunk forwarding, what is our index, and stuff like that. Pretty cool. Other cool thing is the Spring Boot application actually puts in logs here. For some reason, it's not showing up. Give me 1 second. Yeah, sorry, it sometimes kicks me out, but hopefully now it's, yeah, here you go. So all the logs are here, all the traffic coming here. So we just write our application into standard out log. It gets just pushed right here. And for monitoring purposes, we push this to Splunk, but you can clearly see that if there is an issue, you can see it right here. We have some sidecars running where we wanted to move it into Wavefront. So you can see logs for those as well. So every single container that's running inside your pod, you can see the logs for them. And say there's something wrong with this pod, and I figured out, OK, this is not working fine. I just go here, delete it. A new one will spin up instantly once it figures out that I need to delete it. So this is everything that Spinnaker also did. But now let's look at some more stuff that we can see here.
I think you can see this is live. There's a rolling update. It's bringing up a new pod right now. So.
Yeah. It also shows replica sets. So if I click on any one of the replica set, again, the same thing. The concept is same. It shows the manifest of the replica set, how many pods it needs to run, and all of those things. I add something more here. You can see the deployment that it's running in. You can see the service. You can see endpoints. So you can basically have an overview of everything that I need for this environment. It also runs a config map. So we are running this Telegraph config map where it actually even tells us like what it does and what the name of it is, and then what events are fired. And if you look over here, it says status is synced. That means it's synced with GitHub. Everything that's in GitHub is already synced. If it's not synced, it will show a weird red button there saying that it's not synced and maybe unhealthy when it's unhealthy. And the last thing that I really love is it also shows all the ingress stuff that we need for the service. It tells you what the HTTP host, the health check, and stuff like that. Now, as an application developer, I released my code in a couple of hours, or even in minutes, I figured out something's going wrong. I can easily roll back. So what it does is it provides history for the last 5 versions that I've checked it in. So say, for example, I deployed this code with this git revision, and something went wrong. I can instantly go back to the previous one, click here, hit rollback. It will roll back to the previous version, which is stable. So you can have like a fast release and a rollback. Now you would think that we're talking about GitOps, and this rollback is not in sync with the GitHub. But what this does is like it will immediately roll back. Then I go in and update the same Git version. It's really smart in terms of saying that, OK, this image is already running. I'm just going to sync it and not redeploy or do a rolling update again. So in that ways, it's pretty smart too. Yep. So this is just the production version that we have, exact same thing. So every single environment is one application, and if you have an issue in any one of those, you can see it right there. So now this is the CD piece of it. We haven't still spoken about the CI, like when I check in my code into master, what happens. So we use something called as Blueish Jenkins for our CI/CD pipeline. This is like the end-to-end solution. So what happens is, as soon as I check my code into master, it comes here, runs a bunch of unit tests that it needs to, and creates a Docker image in the package. After that, it goes into the dev environment and runs some regression test against it. Then it deploys it into E2E, runs sanity test. Now, you don't see the production environment here because we are still conservative. We don't want every single check-in that we make to go into production. So we created a separate pipeline just to make sure that when we check that in, it goes to production. But our target state is to have a prod box here too, so that we can release fast. If there's an issue, we can roll back fast. So yeah, this gave like an end-to-end overview of like from the time to check in to production. Another cool thing that this is internal, this is not open source, but this is something for cluster management and monitoring. So what this does is we see a bunch of clusters over here. Now you see this one's unhealthy. So for the cluster admin, it needs to actually know what happened. So for that instance, he would just click right on, sorry. Yeah, it's a little slow. You can just click right in there, and then it will show you like all the pods that are running in and which one is a faulty one. For some reason, the Wi-Fi is not opening that one, but you can exactly go in there and see which pod is flaky and figure out what's happening over there. So it's a cool tool for management. And the other thing is, I'm an application developer for validation service. So I don't need to go into a namespace for someone else or account service or whatever and do kubectl or get secrets. You don't want to do that. So how do you manage that? So this gives us write access. So I have access only to my namespace, and I can do get secrets only there. So that is something that we saw. So yeah, that's the demo I had. To talk a little more about Blueish Jenkins, so how did that pipeline get created? It's just a Jenkins file. It remains in your code. It remains in your Git repo itself, and it's customizable. So say, for example, validation service only needed 3 pre-prod environments. Some services might need 5, 6. So depending on that, you can customize it, run regressions. So it's not like you have to do this set of things for every single application. So that saves us money too, because some of our applications don't even need so many pre-prod environments. Gives a complete CI/CD view. And when we were doing this, we were already live in Spinnaker. We wanted to make sure that we are not, making sure that it's highly available and customers are not getting impacted. So what we did is that we enabled parallel deployment, where it was running with classic Jenkins pipeline with Spinnaker in US West, and together we created a separate pipeline with Blueish Jenkins with Argo CD in East. That way we created an HADR site and flipped traffic once we were comfortable. Eventually we will get rid of the Spinnaker pipeline, but this is something that when you're migrating, you can do and make sure that your application is always available.
So the key here is basically with our existing Spinnaker deployment, we use the classic Jenkins, the Jenkins 1.0, which uses different artifact for build. When we move to the new pipeline with Kubernetes, we're actually using Blueish Jenkins 2.0, which only look at the Jenkins file.
Right.
So essentially think about it, basically we have a same repo, but we can actually kick off 2 different pipelines because each build system uses different artifacts for the build. That's pretty much how we kind of cheated.
Right. So yeah, just going over that, Spinnaker versus Intuit modern SaaS with Kubernetes, the CI build from 14 minutes, we went down to 4 minutes. For code deployment, from 90 minutes, from like baking the image to going through all the pre-prod environments into production was 90 minutes. We could achieve it in almost 20 minutes. Release time was, again, 18 minutes because it bringed up 3 instances, deployed the code, ran a regression, so that piece took 18 minutes. Over here, it was 3 minutes, rolling deployment, and EC2 is already up. You're just getting the pods up and running, so it's just the time Spring Boot application takes to come up. The exact same was rollback because it does the exact same thing. It just brings the new instances. So yeah, that's about it. We achieved this, and we are trying to reduce the code deployment time more, but that's about it. Thank you. If you have any questions, yeah, sure.
How do you manage secrets injected in your deployments?
Yeah. So the question was, how do you inject secrets in your CI/CD pipeline? So we use kubectl get secrets based on namespace. So it's not pipeline specific, and we have an Intuit specific way we put in secrets. So that's completely separate. So that's a one-time thing, and in Git we actually point to that in the Git repo, in the deployment repo, we actually mention that, hey, look at this place and get the secrets. So that's part of Git itself.
Yeah. It's just like the config maps and the secret both got injected.
Yeah. Next question. Yep.
How do you trigger Argo when Jenkins pipeline starts?
So the question was, how do you trigger from the Jenkins, from Jenkins 2.0 Argo CD, right? So Jenkins file itself has a combination with Argo CD. It understands we do like Argo start, like create and then do it. So it's like in the Git Jenkins file itself, we call Argo with like the username and password, and it connects it.
There's a Git hook to first of all trigger the Jenkins job to execute, right? Within the Jenkins file, we actually use, and I don't know if you have the source code, but basically is we actually use a container that has our Argo tools in it, essentially, and then we inject the secret from the Jenkins folder secrets, right? That's how we kick it off. Yes.
Yeah.
So how does it compare with the Spinnaker Kubernetes PD provider? There's also a Kubernetes provider in Spinnaker, which like does basically all of the stuff you showed, like it has continuous deployment features like pods, datasets, and so on. So do you have a comparison with that?
So the question is, do we have a comparison with the Spinnaker, with the cloud driver? The answer is no, we haven't gone that far. It just basically, we review the UI, plus, like I said, the two things we consider. The UI itself is kind of more EC2 native, because when we go through the screen, basically, we've been using that screen for more than a year. So we kind of know it doesn't truly represent all the Kubernetes resources like deployment. Part is like EC2, but there's also concept like your ingress, your service. All those things are not in there. The other thing is we like to embrace GitOps. There's no infrastructure as code with Spinnaker, right? Because Spinnaker stores everything in database. So those are two things. That's why we decided not to use it.
Actually, there's a Kubernetes V2 provider which has like very recently came up.
Okay. I see. We haven't gone through the evaluation, so sorry.
How do you handle representation of CRDs?
How do you? I guess this is something that we have. Our team is adding these as we go. You know, if there's new CRD type, we can add it. Like for example, we started out with just deployment set and pods. Now we see all the even config maps is added, right? So.
A follow-up question: is there an easy way to plug in to, for example, allow support for?
Okay.
Like if you're using something like Istio, where it has gateways instead of ingress.
So, so the question is that easy way to plug it in? The answer to that is come to our booth. Our developer on Argo CD is there, so talk to them. Actually, we are more the team that actually help drive the use cases and put it together. But the actual developer is actually at a booth. So come to the booth and talk to them.
Yep.
Okay, the question is what about Helm integration? So I think I kind of skipped that. When we first look at Helm, the way I thought about it is, at least a lot of us thought about it, it's more like a release package, release manage. Like, for example, there's a Helm chart for Spinnaker, right? I can just run that and install 6 different pods and run my Spinnaker. We didn't find it fit our build more for continuous deployment. That's why we didn't, go with that. That's to me is more like a release manage, release packaging. So.
Yep.
What about one of the most important things about Spinnaker is actually the integration with Kayenta, which is a canary analysis. Do you have plans to actually integrate that?
Actually, it's funny. We just okay. The question is, any plan to integrate Kayenta? Yes, we just did a POC last month. Yes, we almost had it all together. We're about to put that out there, hopefully early next year.
That's the reason we had Jolokia container running in,
Right.
and that will forward it to Kayenta and into
Yeah.
Frame.
So the sidecar he mentioned, like added for the Dolokia and Telegraph. That's for us to pump metrics out into wavefront so that we can do comparison. So K8s can pick up the data.
So that's something we're working on right
Yeah.
now. Probably early next year, we will
Right.
have Canary support as well.
Because Canary came out, I used to work for Netflix 6 years ago, so I worked with a guy that did it, so that's why I like to get it in there.
Any other questions? Oh, yep. For the clusters?
No. The
okay.
The question, do we have access control for the UI? Yes, so we integrate with Git permission. Basically, single sign-on through Git, and then so it enforces the same folder structure. Yes.
Yeah. Yeah, that was the same question here. Do you support Canary deployments? So we are doing a POC on that right now, and we're going to using K8s, Telegraph, and Dolokia.
So the person you talk to right there, Danny,
Yeah.
he's the man for us.
He's doing the POC right now.
So he's working with the POC, so the Canary release. We have experiment with blue-green, but for the most part, we're trying to stick with the rolling updates. Unless we have to, then we go back to blue-green.
Right. Cool. Thank you, guys. Please visit our booth. And if you have any more questions, thank you.
And we're hiring. That's right. I forgot.